Problem 1. Using 2's complement, subtract the given binary numbers. So m is equal to the first number and n is equal to the second number, the minuend and the subtrahend. So m minus n can be written as m plus minus n. So this is a negative number. Complements are used to represent negative numbers. So let's find the complement of this number n. So the 2's complement, we are using 2's complement. So the 2's complement of this number can be written as this is the 2's complement of this number n. So how we get this is, first there's a shortcut method to find the 2's complement. First you have to write the least significant zeros as it is. How many zeros you have in the least significant as a significant digit, so you have to write as it is. So the 2 zeros are there, we can write it as it is. Then the first one what you find in the least significant first one you have to write as it is. Then the rest of the number you have to change the zeros to 1 and ones to 0. So here the 0 is written as, these are the least significant zeros, these are written as it is. Then the first one we find is written as it is. Then the rest of the number you have to change the zeros to 1 and the ones to 0. So this will give the 2's complement. It's an easy method to find the 2's complement. Next we have to add this number, the 2's complement number that we got, with m. So for this we have found the 2's complement for this number, and now we are going to add that number with m. So m is this, then we have to add this with this one, the 2's complement. When you add, you get this number. Here there is no end carry. When you add in this place, there is no, you don't get a carry over here. There is no carry over here. So what you have to do is, since there is no end carry and the digit and the most significant digit here is 1. So here the answer is a negative number. The answer you get is a negative number. So you have to find the 2's complement of this number. So the answer will be minus, I said since there is no end carry and here the MSB bit is 1. So it is a negative number, and you have to find the 2's complement of this number. So the 2's complement of this number is this. So this is the answer. So this is the answer. Problem 2. Using 2's complement, subtract the given binary number. So m and n is given. So m minus n can be written as m plus minus of n. So this is a negative number, so we have to find the 2's complement of this number. So the 2's complement of n is this. So you can use the procedure as I said in the previously, you can use here to find the 2's complement. So here we can just do it. Here there is no least significant zeros, so you have only the first one, you find the first one, so you write the 1 as it is. Then the rest of the numbers you can change the zeros to 1s and 1s to 0. So you will get the 2's complement. Then after finding the 2's complement, you have to add this number with m. So m, then the 2's complement of n. When you add, you get this number. So here there is a end carry. This is the end carry. So here you have to discard the end carry. So this end carry you should discard it. So the rest of the number is the answer. Since there is a end carry and the after discarding this number, the end carry, you can see in the MSB there is a 0. So you know the answer is a positive number. So the answer is a positive number, and this is the answer. After discarding the 1, the rest of the number is the answer. Problem 3. Using 1's complement, subtract the given binary number. M and n is given. So m minus n can be written like this. So here this is the negative number. So you have to find the 1's complement of this number. So the 1's complement of n is this. So to find the 1's complement, you have to just change the zeros to 1 and 1's to 0. So you will get the 1's complement. Now you have to add the 1's complement with m. So you will get so after adding you get this answer. So here there is no end carry. So since there is no end carry and the number in the MSB is 1, you know the answer is a negative number. So from this we can understand that m is less than n. So it is a negative number. So we have to, so in the answer we have to find the 1's complement of this number. Again we have to find the 1's complement of this number. So the answer is minus of the 1's complement of this number. So the answer will be minus here you have to put here, then find the 1's complement of this number and write as the answer. It's a negative number. Problem 4. Using 1's complement, subtract the given binary number. M and n is given. So m minus n is equal to m plus minus of n. So negative number, this is n is a negative, n becomes a negative number. So we have to find the 1's complement of this. So the 1's complement of n is equal to this number. Just convert the zeros to 1 and 1's to 0, you get the 1's complement. Now add the 1's complement of n with m. So when you add, you get this as the answer. Here you have the end carry. This is the end carry. So here in 2's complement method, when we do, if we get end carry, we will just discard the end carry and write the rest of the number as the answer. But in this 1's complement method, we should not discard the end carry. What should you do is, we should do end around carry. So end around carry means, what should we do is, we should bring this carry, the end carry, we should bring this carry here and we should add this carry with the sum. So here you have to bring this carry over here and add it with the sum. So when you do this, you get this as the answer. So here, so this is a positive number. Since it is there's a end carry as well as it begins with the number, the MSB bit begins with 0 and also there is a end carry. So the answer is a positive number. So this is the answer. Problem 5. Using 2's complement, solve 57 minus 27. Here these numbers are decimal numbers and we are going to use 2's complement to solve this number. So 2's complements are, 2's and 1's complements are always used for binary numbers. So here we have to convert this 56 and 27 to a binary number. So when we convert So 56 is m and 27 is represent n. So when we convert, we get this as the binary number. So m minus n can be written as m minus m plus of minus n. So we are using the binary numbers now. So now the same procedure as we solved before, same procedure we are using to solve this problem. After finding the binary, we have to use the same procedure to solve the problem. So here we have to find the 2's complement of this number n. So this is the 2's complement of the number. Then we have to add it with m. So m n 2's complement of n plus, when we add this, we get this number. Here there is a nth carry. So we have to discard the nth carry. So discard the nth carry, and now the MSB bit here is starts with 0. So here the answer is a positive number. So this will, after discarding the nth carry, the rest of the number is the answer. Then again we have to we have to find the decimal number for this binary number. So for this binary number, the decimal number equivalent is 29. So 56 minus 27 is equal to 29. This is the answer. Problem 6. Using 1's complement, solve minus 42 minus 20. So these are decimal numbers. So now we have to find the binary equivalent of these 42 and 20. So for m represent 42 and n represent 20, and we have to find the binary equivalent of these numbers. So we have found the binary equivalent. Then m minus n can be written as, here, minus m minus n. So minus m plus minus n. So here we have two negative numbers. So m is also negative and n is also negative. So we have to find, I said complements are used to represent negative numbers. So we have to find the complement, 1's complement of m, and also the 1's complement of n. So the 1's complement of m is this number, and the 1's complement of n is this number. So after finding the 1's complement of these two numbers, we have to add them both. When we add them, we get this number. Here we can see this number has a nth carry, and also so we have to, there is a nth carry. So we have to bring this carry down and add this carry with the sum. So here we have brought this 1 down here, and we are adding this 1 with the sum. So when we add it with the sum, we get this number. Here in this answer, what we get, we can see the MSB is 1. There is a 1 in the MSB. So this 1 represents that the answer is a negative number. So we have to find the 1's complement of this number again. So the answer is negative, so you put minus, then you have to find the 1's complement of this number. So the minus of the 1's complement of this number is this. Then we have to convert this number to the decimal equivalent, since the sum is in decimal format. So we have to convert the binary to a decimal number. So the answer is minus 62. So the decimal equivalent of this number, this binary number, is 62. So this is the answer. So minus 42 minus 20 is equal to minus 62. Using 2's complement, solve the hexadecimal number C4 minus 7b. So these two numbers are in hexadecimal format, but we have to find the 2's complement. So 2's complements are for binary numbers. So we have to convert this hexadecimal number to a binary number. So M represents C4 and N represents 7b. So these are the binary equivalent of this hexadecimal number. So how we get this is, for C represent the 4 bit, that is 1100 is represents C, and for 4 another 4 bit, that is 0100 is the binary equivalent of 4. Again 7b, for 7 the first 4 bits, that is 0111 is for 7, and for B the binary equivalent is 1011. So now M minus N can be written like this: M plus minus of N. So this is in binary form we are writing. So we can now find the 2's complement of this N. The 2's complement of N is this number. Now we can add this number with M. So when you add, you get this number, and there is a end carry. So here the end carry is there. So you can discard the end carry, and after discarding the end carry, the MSB bit is a 0. So there the answer is a positive number. So the answer is this. That is, you write after discarding 1, you write the rest of the number as the answer. This is the binary number, but you need the answer in hexadecimal because the sum is in hexadecimal. So the problem is in hexadecimal, so you need the answer in hexadecimal. So for this, take the first four bit. So the first 4 bit represent 4, and the next 4 bit represent 9. So the answer is 49. Problem 8. Using 1's complement, solve the octal number 25 minus 7 3. So the problem is in octal format. So we have to find the binary, since we need the 1's complement. 1's complements are used to represent binary numbers. So we have to convert this octal number to a binary form. So M and N, 25 is M and 73 is N. So we have converted it into a octal number. So here each 2 represent a 3-bit binary number, 0 1 0, and 5 is 1 0 1. Same here, 7 is 1 1 1 and 3 is 0 1 1. Then M minus N is written as M plus minus of N. So this is a negative number. So we have to find the 1's complement of this number N. So the 1's complement of N is this. Now we have to add this with M. So when we add it with M, we get this number. Here there is no end carry. There is no end carry. So we know, since there is no end carry, we know that M is less than N. So that is, M is less than N, we know, since there is no end carry. So the answer will be a negative number. So we have to find the 1's complement of this number again. So minus, it's a negative number, so minus 1's complement of this number. So the answer will be this, minus of the 1's complement of this number is this. Then we need the answer in octal format. So it is this, minus 46 is the answer.